I'd like to introduce you to the OPW Electronic Systems EECO tank gauge products so I can give you information on installation, startup, and service procedures for these tank gauges. OPW Electronic Systems is located in Hodgkins, Illinois. We have a technical support department. If you need assistance on our equipment, you may call our toll-free number 877-679-8324 or 877-OPW-TECH. ATG is an industry acronym for automatic tank gauge. Automatic tank gauges are monitoring fluid storage tanks primarily for inventory control and money management. Also, the second important function that they perform is environmental protection. Not only are they used to monitor storage tanks, whether they be underground or above ground, they can also be used to monitor fluid lines, piping, and sump areas where loose product might accumulate if a leak were to occur. The types of monitoring offered by the OPW EECO gauges are inventory monitoring, static leak detection, segmented leak detection, leak sensor monitoring, precision reconciliation, and if one of the EECO tank gauges is interfaced to the Incon TS LS300 pressurized line leak system, it will operate as an interface to that system to supply pressurized line leak detection on pressurized product piping. The two gauges in the EECO family are the EECO 1500 and the EECO 2000. The EECO 1500 will interface to either 2 or 4 tanks. It has remote and local communications capability. It will control 8 liquid sensors. It can be interfaced to a generator monitoring circuit and offer pressurized line leak detection when interfaced with the Incon LS300. The EECO 2000 has a capability of 8 tanks, remote and local communications. It will interface to up to 24 liquid sensors. It will provide inventory reconciliation when connected to fuel dispensing equipment, and it will also give you the capability of pressurized line leak detection when it is interfaced with the Incon LS300 pressurized line leak system. The EECO 1500 specifications. On this slide you can see the dimensions, the weight, the operating temperature, humidity. The important fact on this list is this device is designed to be installed in an environmentally controlled atmosphere. Above freezing, below 104 degrees Fahrenheit, less than 90% humidity. Indoors only, non-hazardous. It will operate on either 115 volts AC or 230 volts AC, but we require a 15 amp dedicated circuit for power. It will generate automatic reports. It has a membrane style keypad. It has a 2-line by 20 character LCD display. It has a thermal printer. It has 2 standard built-in ports. One port is an RS-232 port that can also be used for specific functions. A secondary port is a standard external modem connection port that can also be designated as an RS-232 port. It has one built-in standard relay that is programmable to operate on any or all alarms or troubles generated by the EECO 1500. In addition, you can purchase an optional relay board that contains 4 additional relays that can be programmed. The EECO 2000 is a larger system than the EECO 1500, but it is also designed to only be installed in an environmentally controlled atmosphere. So again, above 32 degrees Fahrenheit, less than 90% humidity. Power requirement is 120 volts AC. Again, it requires a 15 amp dedicated circuit. It has programmable reports. It has a keypad. It has a 2-line by 20 character LCD display. It has a impact printer. And it has an internal system relay that is not programmable and activates on any alarm or trouble. As with the EECO 1500, the EECO 2000 will also support additional relays in an optional relay board, 4 relays per board, but the EECO 2000 will control up to 2 additional relay boards. The EECO 2000 also has RS-232 interface capability. With the RS-232 expansion board, there are 3 ports, 1 port for an external modem, 1 port as a pass-through port that you can connect to the EECO 2000 from externally and pass through to another device, and a local RS-232 port. When equipped with an external modem, it can be programmed to auto dial out on specific alarms or troubles and notify another device externally. Both systems will give you programmable shift times, complete inventory reports, delivery reports, low inventory alerts, will generate alarms for leak, overfill, high water, low inventory, leak test required, external inputs, and other programmable alarm limits, all as standard functions. For in-tank leak testing, both units can perform a 0.2 gallon per hour tank tightness test, static test, a 0.1 gallon per hour static test. Both units will optionally perform continuous statistical leak detection to a 0.2 gallon per hour leak test with the option that is referred to as segmented leak detection, or SLD. Both units can perform leak tests on a manifold tank group of 2 tanks with the optional SLD function. Both units can perform leak testing on tanks that are larger than 20,000 gallons but less than 35,000 gallons with the optional SLD function. Both support programmable automatic test schedules. You can program to test all or single tanks. They both perform validity checks on the leak tests that they perform and will issue either a pass or a fail or an invalid or inconclusive indication on the test. And both can be programmed to notify you if a test has not passed and a test is due. For line leak detection, when interfaced with the Incon TS-LS300, both units will perform 5 different tests on a pressurized line leak system. A 3 gallon per hour catastrophic leak test, a 0.2 gallon per hour monthly precision test, a 0.1 gallon per hour annual precision test, a pressure up test when a submersible turbine pump starts, and a pressure hold test when a submerged turbine pump stops. When a unit is performing a standard or a static leak test, there are 2 methods of programming. One method is manual, one method is continuous. Continuous static leak detection is not to be confused with segmented leak detection. What it means is when a tank is programmed for a manual test, you are telling the unit at what date, day, time to perform the test on that tank. Now that tank must be inactive during the entire period of the test. Continuous static leak detection means that the unit is monitoring the tank. When it sees that the tank is idle, it will then launch a static leak test automatically. If the tank goes active during the test, it will abort the test, wait for the tank to go idle again, and begin a new static test. If the tank is inactive during the entire period of the test, at the end of the test it will post a result to history, but it will not print out a result. If you program a manual test, at the end of the manual test, if the test result is deemed to be a pass, it will print out a report of a passed leak test. If the test result is deemed to be a fail, it will alarm and print out a failed leak test report. If the test is inconclusive, it will print out an inconclusive test result and launch a second test in an attempt to pass. If you have the system programmed for continuous static leak detection, if it performs a test and the result is a pass, it will store that passed result into history but will not print it out. If the test result is an inconclusive, it will launch a second test. If the test result is deemed to be a fail, it will print out the fail, issue an alarm, and again begin a second test after the fail. The standard static leak detection is EPA certified for 0.2 gallon per hour and 0.1 gallon per hour, with both the old 4-inch floats used on the Q0400 probes or on the new 2-inch floats used on the replacement for the Q0400 probe, the TLM probe. These tests are valid on single tanks only, up to 20,000 gallon capacity, when the volume is between 14% of full volume and 99% of full volume. A 0.2 gallon per hour test will generally take up 2 to 4 hours, but possibly longer. A 0.1 gallon per hour test will take from 2 to 6 hours and sometimes possibly longer. The test lengths do depend on the tank conditions. The unit will determine the length of the test when, at the start of the test, it looks at the size of the tank, it looks at the volume in the tank, and it looks at the temperature. At that point, it determines how long that test will run. Therefore, you can program a manual test to begin at a specific time. However, you cannot program a test length nor an end time for the test. And no test will be performed within 6 hours of a delivery into the tank. A static leak test report will show you when the test began, when the test ended, all the pertinent information that you need. It'll tell you the RTD or resistive temperature device readings on the probe, the water level. It will tell you a result at the bottom. On the test result will be passed, failed, or inconclusive. It will give you a leak rate and tell you if that leak rate is an increasing volume or a decreasing volume in that tank during the period of the leak test. Other prints that you'll get from static leak tests are shown on this slide. If you look at them, you could see that starting at the left and moving by columns over to the right, that first printout is where you have programmed for a tank to start testing right now, but for some reason the device has determined that the conditions aren't yet right to begin testing that tank, and it will give you a projected start time. Or it will tell you if there's a system or TLM trouble that's going to prevent a tank test from running. If a tank test has started on a manual test and somebody begins using product from the tank, if the system can then identify pump activity, it will abort the test and tell you. It will tell you if you failed a leak test and show you the leak rate. It'll tell you if it's an inconclusive result, or it will give you reasons why the leak test cannot be performed. Segmented leak detection is intended for hours that are deemed 24-hour sites or are pumping day and night and do not close. It is certified for a manifold group of up to 2 tanks, a total capacity between the 2 tanks of 35,000 gallons, and a total throughput per month of the manifold group or the single tank of less than 130,000 gallons. It is certified as a 0.2 gallon per hour test only. The system monitors the tank similar to the continuous static test, and when it sees that the tank is idle, it will then start collecting data in segments. A segment of data, minimum size is 18 minutes, maximum size up to an hour. So if it can collect the whole 18 minutes, once the tank goes active, again, it stops collecting the data and stores that segment that it collected. It will then add those segments up over a period of time to build a database for the tank and then be able to issue a test result. As with the static test, it will collect no segments within 6 hours of a delivery. When the SLD function is first started up in a unit, the first test results will be posted depending upon several conditions. For a standard tank under 13,000 gallons, single tank, it requires a minimum of 15 hours of data to be able to declare the first test result. For manifold tanks or large tanks, it requires a minimum of 2 conditions. The first condition for manifold tanks is 25 days, and over that 25-day period, it must collect at least 40 hours of data. For a single tank over 13,000 gallons, it requires, again, 25 days, but over the 25 days, 15 hours of data. It will constantly update the database with new data. Once the database is full, as new data is collected, older data will be pushed out of the database, so the database is always a rolling current tank information. Should a leak test fail, or should a leak test generate an inconclusive 5, and I will explain an inconclusive 5 in a later slide, it will then discard all the data in the database and begin again. With the SLD option enabled, there are comprehensive diagnostic reports that are available, and when you look through the printed materials that are supplied, you'll be able to see the commands to issue those diagnostic reports. Leak test inconclusive codes. Code 1 is excessive temperature changes during the test. This could be due to recent delivery of hot or cold product, or a large pumping of product drew a large amount of hot or cold air into the tank, a drifting measurement, or an above ground tank. Now, above ground tanks cannot be tested because the temperature is never stable enough to perform a valid test. Code 2 inconclusive is data quality check fail. That just means that the data is not sufficient for the test. This can be caused by surface waves, thermal currents, a float that's at a transition point, or excessive vibrations for overhead traffic. When the EECO conducts a static leak test, it actually conducts 2 tests, Test A and Test B, and compares the results of those 2 tests. If you receive an inconclusive code 3, it means that the leak test results between Test A and Test B are excessively different and indicate a leak rate of greater than 3 gallons per hour. This can be caused by the structure of the tank being unstable, a recent large change in product level, submerged turbine pump activated during the test, or even if someone checked the product level in the tank using a manual stick during the test. And inconclusive code 4 is similar to the 3 with the exception that the leak rate indicated is less than 3 gallons per hour, but greater than allowed during the test. And again, the same conditions that would cause a code 3 can also cause a code 4. An inconclusive code 5 is an indication that product is leaking back into the fuel storage tank. The product level is increasing with no corresponding increase in water level. This can be caused by a leaking check valve in a submersible pump. It can be caused by a leaking check valve for a suction pump, or it can be caused by product leaking back into the line from a vapor line or an improperly installed vent line. As mentioned earlier, an inconclusive code 5 will cause segmented leak detection database to be stopped, emptied, and the SLD test started all over again. Factors that can cause leak test problems are incorrect probe setup and calibration. An accurate test is incumbent upon the tank properties to be properly input into the tank gauge. We must know the correct tank size, shape, volume, product, and the probe setup must use the correct settings for the probe, and the probe must be calibrated properly. If vent lines are obstructed that cause changes in tank ends due to pressure or vacuum, that can affect a test. Fill caps leaking, heavy gusting winds across the vent could cause products to start moving back and forth, wave action in the tank. A changing water table. As the water table comes up and down around the tank, it can cause great temperature differences to appear in the tank. Those can all affect leak tests. One thing not mentioned here that can also cause problems with the leak test is if you have a tank that is not used very often, the product in that tank tends to layer out in different temperatures, and because we have different temperature levels in the tank, that will also affect tank testing and will usually give you an inconclusive test result. The next section we're going to look at how the hardware of the system is laid out and how the information flows within the tank gauge system. Looking at the EECO 1500, it's a fairly simple layout. There is a single main board in the unit. On that main board is the interface for all probes and sensors in the intrinsically safe section. On the main board is the leak sensor communication circuits, the tank probe communication circuits, relay control circuits, processing, all on one board. There is a separate power supply that is mounted on the chassis of the unit. There is also a second power supply on the main board. The power supply on the main board is only used for probe voltages. So you see in a simple form, the probe that's in the tank feeds data to the probe connection on the main board, which then gets fed and processed in the main board and out to the display and the printer. For the EECO 2000, it's a bit more complicated because the EECO 2000 architecture is built on a card cage concept where there are separate circuit boards in the card cage performing specific functions that are all done on the same board in the EECO 1500. So in the illustration that we're looking at here, the tank probe connects to a tank level monitor probe interface module, which then feeds into a tank level monitor driver board, which through the backplane board is connected to the MPU or processor board, which then feeds data to the auxiliary board, and the auxiliary board then feeds data to the display and to the printer. On the EECO 1500 main board, the layout that we show here, you can see that the AC power is in the lower left corner. Above the AC power connection and the relay connection is a slot to install an optional 4 relay board. Above that 4 relay board, you'll see a transformer and what looks like power supply circuitry. That is the power supply for the probe voltage. But above the transformer on the left-hand side of the board, you'll see some black wires that are labeled DC power. This is the power input to the main board from the external power supply that's mounted on the chassis. And above that, we see the 2 external 9-pin ports that are standard on the board, one standard local, one standard external modem. In the upper right corner, you'll see some integrated circuit chips that are labeled. Those are the EEPROMs, the memory chip, the TLM driver chip, a PAL chip, and then you'll see also the battery, 3.6 volt lithium battery for memory retention. That battery is good down to a level of 3.0 volts DC minimum. There is a jumper next to the battery labeled JP1. That jumper must be on for the battery to be in the circuit. When a 1500 unit is shipped or a board is shipped, it is normally shipped with the jumper off so that the battery is not active into the circuit, thus minimizing any drain on the battery unnecessarily. On the lower right are the connectors for the probes and the sensors. Above that, you'll see the intrinsic barrier. What's not shown in this illustration is that when normally installed in the case of the EECO 1500, there is a metal cover that goes around the intrinsic section to isolate it from any high voltage that it might come in contact with. If the EECO 1500 SLD option is installed, that requires a EEPROM change from the normal static test EEPROMs and a jumper change on the upper part of the EECO 1500 main board. What we show you here is where those jumpers are and the positions they get changed to when that option is installed. The EECO 1500 power supply mounts on the chassis as mentioned earlier. On that power supply is only one adjustment, the 5 volt DC adjustment, which is a potentiometer that can be adjusted. That 5 volt adjustment also affects the 12 volts, but it's primarily used for the 5 volts. Then the output of this power supply is fed through that connector that's labeled DC power to main board through wires that go down to the main board. The keypad assembly and display are all on a single board. The display has a contrast adjustment that is accessible when the board is installed so that you can adjust the viewing angle depending upon how the unit is installed, whether it's on a line of sight or needs to be adjusted to make it more easily viewable. The voltage test points on the main board are on the left-hand side of the board to the left of the cable connector that goes to the main board. On the board, you'll see a set of diodes and green pico fuses. Each pico fuse is one of the voltage outputs of the power supply. We have them labeled here, plus 12 volts, 2 plus 5 volt outputs, and 1 negative 12 volt output. Also is labeled the where the black wires connect to the board. If you follow those black wires back, you can actually check the voltages on the connector on the power supply itself. The 5 volt DC is normally adjusted to between 5.05 and 5.11 volts DC regulated. The 12 volt DC output is non-regulated, somewhere between 11 and 13 volts normally. The EECO 1500 supports 2 different thermal printers. The original thermal printer is no longer manufactured. That's the printer that's on the left. That printer Q439446, designated as the old style printer. It's identified by the fact that the cover comes off of the printer slides out towards you from the door. That's how you would change the paper in the printer. There is no ribbon because it's a thermal printer. As I said, that printer is no longer manufactured. Should you have one of those and that printer fails, you need to get the 439763 new style printer. And the way that you can tell that it is the new style printer is it has a release button and the door actually swivels open. And as the door swivels open, the paper spool comes out where you can change the paper easily. That printer is a different size from the original printer. It will not fit on a EECO 1500 door that supported the old style printer. So if you have an old style printer and you need to order a new style printer, you can purchase a kit, part number Q451360, that will include the door, because the cutout on the door needs to be enlarged for this new printer. Now, there is no price difference between the kit and the printer, replacement printer itself. So when you order that kit, you will only be charged for the printer. In that kit, you should receive the printer, you'll receive the door, and you'll receive a overlay to go on the door over the keypad. The new printer is not fully compatible, not fully backwards compatible with the EECO 1500. If the software in the EECO 1500 is too old, what will happen is any printouts on the new printer will, instead of starting at the top of the paper and print down, will start at the bottom of the paper and print up. So if your EECO 1500 is equipped with software versions prior to version 23M, version 83H, or version 87D, that's what's going to happen to you. You will need to upgrade your software to a later version in order to have the printer print from the top down. The EECO 2000 works with a main board, backplane board, and a card cage where all the other circuit boards will plug in 2 slots on the card cage. While you see that some of these slots are labeled, the slots in the card cage are essentially identical. You're not locked into plugging a certain board into a certain slot. You have some leeway in where the boards are installed in the slots dependent upon what cables are connected to the boards, usually installed to give you the least amount of interference. On the right hand side of the card cage is where the main power supply would be installed. That power supply supplies all the voltages for the main unit and the sensors. The probe interface module has a separate power supply to supply power just for the probes. Below the card cage are test points where you can check the voltage outputs of the main power supply. 5 volts, 12 volts A, 12 volts B, and ground, and negative 12 volts. The 5 volts is normally adjusted to a level of 5.08 to 5.15 volts, nominally 5.1 volts DC. That is a regulated output. The 12 volt outputs are not regulated and normally between 11 and 13 volts DC. Down in the lower right corner of the board is where the AC power is connected, also where the included internal relay connections are. Above the high voltage connection points is a smaller cage where either 1 or 2 multi-relay boards could be installed as an option, or if you use the TCP IP interface function, that board would be installed in that small relay board card cage. In the lower left corner of the board you see J16 that is labeled Printer Power Use Care. That is a 4-pin connector and it is not keyed, so if the printer power plug is removed from that connector, there's a possibility it could be plugged back in incorrectly, moved over 1 pin. Should that happen, you will damage the printer controller board and you will also damage the main power supply. If the main power supply loses 5 volts completely, you need to check to make sure that that has not happened, that someone has not plugged that connector in wrong. If they have, when you install a new power supply and turn the power on, you will blow the new power supply. So if you are not sure if that condition has occurred, when you replace the power supply, you will also want to replace the printer controller board. The EECO 2000 used to be supported with two power supplies, a single power supply and a dual power supply. The single power supply is obsolete and is no longer used. The single power supply was used in units that only interfaced to probes. We now have a dual power supply. The second half of the power supply in the dual power supply supplies the voltages for liquid sensors and line leak detection sensors. The 5-volt output of the power supply is adjustable. When looking at the dual power supply, both circuit boards do have an adjustment potentiometer. However, only one can be reached without disassembling the power supply. That is the 5-volt adjustment. In order to adjust the 5 volts on the power supply, what you'd have to do is remove power from the unit, remove the power supply, make the adjustment, reinstall the power supply, turn the power back on, and check your voltage. So it's kind of a trial and error method, but you can see that 1/8 of a turn is approximately 1/10 of a volt DC. That gives you a guideline on when working with adjusting the power supply. If the power supply is too low, what you will see as a symptom is when the printer is being used to do a printout, at the end of the printout, the printer prints a row of asterisks. That is the point of maximum current draw for the printer. If at that point the EECO reboots, it's an indication that your 5 volts is too low, and it should be up at around 5.1 volts. On the slide that's being indicated now is the functions of the auxiliary board, which is normally the first board in the first slot on the left-hand side of the card cage. On the right is the dispenser power interface. That is a unit that used to be manufactured that is now obsolete. It is no longer available from OPW. However, the auxiliary board also supplies control for the keypad, display, printer controller, and printer assembly. The display has a contrast adjustment, but the contrast adjustment is not accessible when the display is installed on the unit, so you would have to remove the display board from the door, make the adjustment, put it back on the door, and then check to see if the adjustment was suitable. The printer mechanism installs underneath the card cage. Depending on the age of the unit, that printer mechanism may slide in and out of the unit, or it may fold down or swivel down for paper replacement. If it is the swivel down type, you see the bottom of the printer is a connector with white wires connected to it. If you have the type of printer where the printer swivels down to replace the paper, you need to be aware of the fact that over time that connector may come loose from swiveling the printer open and closed. The EECO 2000 family supports 3 different MPU boards, multiprocessor boards. The original board is the Q439936. That board is obsolete, no longer installed, no longer manufactured, and there is no return core credit available for that board. That board is recognizable by the 3.6 volt lithium battery that's installed on the board, by the fact that there are 2 random access memory or RAM chips on that board, and there are 4 EEPROM chips on that board. That board was replaced by the Q439972 MPU board. That board is recognizable by the fact that it has the larger 3.6 volt lithium battery on it, but it only has one RAM chip on the lower part of the board and still has 4 EEPROMs on that board. That board still has a exchange credit if you purchase a new MPU board, but this board is also obsoleted. The current production MPU board for the EECO family is the Q439992, also called the 386 board. That board's distinguishable by the Intel i386 chip that's on it. Also, the fact that the lithium battery that's on this board is the disk type and not the cylindrical lithium battery that has been seen in the past. This board also has a connector on the bottom of the board to connect a cable that splits into 3 9-pin connectors, because this Q439992 MPU board does support external communications. So there are 3 ports that are programmable for different functions, whether they might be local communications or to reconciliation equipment or to line leak detection equipment. When the 386 or Q439992 board is installed, a Sidekick board is required for proper operation. The Sidekick board is recognized by being just a yellow board that has 4 resistive networks that are soldered on the board. This board normally would go into the extreme right-hand slot of the card cage next to the power supply. This is the only board that must be in a specific slot. The TLM Driver Board, Q439940 board, is the same board that's been used in all of the EECO 2000 family. On the board are 3 removable chips. The tank table chip, current version 019C. The TLM driver chip. The current version actually of the TLM driver chip is 4.30. The illustration shows the earlier 2.30 chip. The 2.30 chip on the TLM driver board will support all of the original EECO Q0400 probes. If a original EECO Q0400 probe fails, that probe is no longer manufactured. It has been replaced by the TLMB probe. In order for the EECO 2000 to interface to the TLMB probe, that TLM driver chip must be upgraded to the version 4.3 software to support that probe. It is also backwards compatible to the original probes. If you have to replace a probe and you order a TLMB probe, you will receive with each probe a 4.3 version software TLM driver chip to be used on the TLM driver board. The leak sensor line leak detector driver board. The system will support up to 2 of these boards. When used for a leak sensor driver, each board will support up to 12 sensors. Driver board number 1 would be sensor 1 through 12. Driver board number 2 would be sensor 13 through 24. When used for line leak detection, board number 1 is line 1 through 4. Board number 2 is line 5 through 8. The board is also distinguished by the fact that it has a connector on the top of the board and 2 connectors on the front edge of the board when the board is installed into the unit. The connector on the top of the board is for the cable that runs to the leak sensor interface modules, and the boards on the front would be to the line leak detector interface modules. There are jumpers and a replacement or replaceable chip on the board. The hardware between the board number 1 and the board number 2 is the same. The difference between driver board 1 and driver board 2 is the programmed chip and a jumper placement. We show you here on this slide that if you are using driver board number 1, it will have a chip labeled either ELP-V1 or 055A, and the jumper below the chip would be towards the IN2 INT2 position. If it was driver board number 2, you would have a chip labeled ELP V2 or 056A, and the jumper would be towards INT1. You must be cognizant of the fact that if you have two number 1 driver boards installed or two number 2 driver boards installed, your leak sensors or line leak detectors will not function properly, and you will see multiple trouble codes displayed on the unit. The optional RS-232 communications board Q439957 can be installed in the unit. It expands the communications capabilities of the unit. It includes a connection for an external modem, a pass-through connection where you could connect to the EECO unit and communicate to another device that was connected to the pass-through connector, or an additional local port to connect for local communications. If the unit is equipped with the communications board and it is equipped with a Q439992 or 386 MPU board, you'll see a collection of 6 9-pin connectors mounted to the bottom chassis of the board, and those are labeled in the small inset that you see over on the right. The unit used to be installed with the EECO 2000 families of tank gauge supported internal modems that used to be manufactured that are no longer manufactured and are therefore obsolete. These boards are distinguishable from the fact that they have red LEDs on the front edge that can be seen when the board is mounted in the card cage. There were 2 different styles, one with 8 LEDs and one with 4 LEDs. Again, there was a cable from the bottom of the board that went down to the chassis, and of that cable, one was the modem port, pass-through port, and a local port, but in this case, the modem port was a 2-wire adapter connection to the phone line that would then feed to the internal modem. The internal modem used to support both modem functions and fax functions. That is no longer the case. The EECO 2000 no longer supports any fax functions, regardless of whether it is an internal or an external modem. The TLM Interface Module is normally installed in the right-hand portion of the unit. Left-hand portion containing the backplane board, the card cage, power supply, printer, and customer interface. The right-hand side, the interface modules for the external devices. The TLM Interface module is normally the first module. It has 8 connectors on it to connect the field wiring for 8 tank probes. On this module is an internal power supply that supplies the 26 volts DC power for probe operation. That voltage is adjustable, and there is a fuse for that power output to the probes. This has no relation to any other power in the unit. This is separate power for the tank probes only. It does, however, output a 12 volt DC voltage that is not used by the tank monitor portion of the unit, but is monitored by the main processor board. That 12 volts is compared to the 12 volt output of the main power supply, and if a difference is seen between those 2 voltages, then the multiprocessor board will issue a trouble code to indicate a probe voltage problem. The power supply on the TLM interface module is a constant output power supply, so every connection for probe on this module should show the same voltage whether there's 1 probe, 2 probes, or 8 probes connected. Should the voltage drop as more probes are connected, there's a problem with the power supply and this whole module will need to be replaced. If the voltage is low but constant, then it can be adjusted using an adjustment that's next to the transformer on the board. The leak sensor interface module is distinguishable by 6 connectors for 6 sensor inputs. There can be a total of 4 interface modules installed in the unit for up to 24 sensors. Module 1 and 2, or for sensors 1 through 12, would connect to a cable that goes to leak sensor driver board number 1, and the second 2 for 13 through 24 would connect to a cable that goes to leak sensor driver number 2. The line leak detection circuitry that used to be used in the system is all determined to be obsolete and no longer manufactured and no longer supported. So if you see this in a unit in the field, it is probably going to be non-functioning. If it is functioning and a problem arises, OPW no longer has replacement parts for these units. The EECO 1500 AC wiring. On the main board in the lower left-hand corner is the AC power input connector. We have 120 volt AC 15 amp dedicated circuit requirement. 14 gauge stranded wire minimum. You'll notice that it is a 4-terminal connector with 2 ground connections. Those are required for Canada and some other countries. The board is screened with labels for each terminal so that you know which terminal should receive which wire. The EECO 2000 AC wiring has the same requirements: 120 volts AC 15 amp dedicated circuit, 14 gauge minimum stranded wire, again a 4-terminal connector with 2 ground connections, and the power wires connect to that connector, and again the backplane board is screened with labels for those terminals. EECO 1500 conduits and ports. On the bottom of the EECO 1500 are the conduit entry points. If you look at that, to the left 2 are for high voltage, the right 4 are for low voltage or intrinsically safe circuits. We recommend 12-inch clearance on the bottom of the unit for conduit access, and 6-inch clearance on the left side for access to the 2 built-in 9-pin RS-232 communications ports. You're to use only the factory conduit entries. Any other holes that are drilled in the chassis will result in loss of any remaining warranty on the unit. The EECO 2000 conduit and input-output ports. The EECO 2000 has more ports on the bottom. You see that it's actually in 3 areas. We have non-intrinsically safe on the left, which is where the AC power connections and relay wire connections would be. We have intrinsically safe in the middle. That's where the probe connections and sensor connections would be. And then on the right are non-intrinsically safe. That's where the old line leak detector or dispenser power interface connections would be made. Again, we recommend 12-inch clearance on the bottom for conduit access and 6-inch clearance on the left side, not necessarily for communications access on this unit, but for ventilation. And as on the 1500, you're to use only the factory conduit entries. Any other holes drilled in the unit will void any remaining warranty. The next thing we want to look at is installation requirements and practices for the EECO tank gauge family. The current probe being used on the EECO family is the model TLM magnetostrictive probe. It's proven magnetostrictive technology. It provides product level, water level, multiple temperature readings, function in both above ground and underground tanks. The probe head centering disc will allow this probe to be used in probe riser pipes from 2-inch up to 4-inch in diameter. This is a digital probe that, when used with some pieces of equipment, will transmit probe personality data. This probe comes equipped with 2-inch product float and 2-inch water floats. The part number is a Q0400-4 followed by 2 digits for the probe length, or 3 digits depending on the probe length. The letters ER-2 and a letter for the designation on the water float, whether it be a gas water float or a diesel water float. So the example you see, Q0400-408ER-2G is an 8-foot probe with gas water float. Specifications: the operating temperature is from negative 40 degrees Celsius to positive 60 degrees Celsius. The head dimensions are 8.5 inches by 1 inch, allowing this to fit inside a 2-inch riser pipe. The cable is a 6-foot cable. It's certified North America, outside North America, temperature resolution. Probe operation. Magnetostrictive probe, in simple terms, means that the circuitry in the head of the probe sends a signal down a wire that's going down the center of the probe shaft. When that wire sees a magnetic field, a pulse reflects back up to the top of the probe head and is detected by the circuitry up there. Then the main pulse travels the remaining distance of the probe. If there's a magnet down there, it will see that magnetic field and reflect back another pulse. When the initial pulse reaches the end of the probe shaft, it is then absorbed, so there is no reflection. So basically you see a return pulse for the product magnet and a return pulse for the water magnet. The system times the difference from when the pulse left the head until the reflected pulses came back, and using those measurements it is able to compute heights in the tank for both the magnet for the water float and the magnet for the product float. Accuracy of the probe is down to 0.0005 inches. Water level changes to a resolution of 0.01 inches. Linearity, hysteresis, those are engineering terms not normally used by technicians in the field. They're given to you here so that you can see if you are bidding with a specification that's been introduced into the bid process. You can compare this equipment to competing equipment. The probe temperature sensors, there are 5 of them along the probe shaft, and there's an additional probe head RTD that's used as a reference. So the probe sensor RTD sensors are normally installed at 10%, 20%, 40%, 60%, and 80% of the length of the probe shaft. They're used to determine the average product temperature so that the tank gauge can then generate a temperature corrected net volume for the product that's being measured. The probe head RTD is used for a reference, and the 5 RTDs in the probe shaft are used for measuring product temperature. When computing net volume measurements, only those RTDs that are immersed in product are used in that calculation. Any above the product are not used. If the product level's at 50%, then the bottom 3 RTDs are used. The system can be set up to use the bottom RTD for the product temperature even if the product is lower than the bottom RTD. So the product and water floats are, as you would understand them to be, the product floats on top of whatever product might be in the tank. The water float floats on top of the interstice between any product and any water that might be in the tank. The water float has a weight ballast on it so that it will sink through product but not sink through water. The standard float material is a nitro-filled material. Product floats were available in 2-inch and 4-inch. They are now only available in the 2-inch. We no longer furnish a 4-inch product float. The water float is a 2-inch water float that has a white neck for gasoline and a black neck for diesel. There is no neck on the product float. So the product float is normally mounted on the probe with a magnet to the bottom of the float, and the water floats have the magnet at the top of the float. So care must be taken that those two magnets don't come into too close of a proximity with each other. If they do, the magnetic fields will merge and the system will see one float instead of two floats and generate a trouble code that indicates loss of signal. Chemical compatibility. Just make the statement here that all of our probes and all of our floats are designed to work in petroleum-based products. They will work in some chemical products. They're not guaranteed to work in all chemical products. In some cases, you may need to use stainless steel floats instead of nitrile floats, and in some cases, neither float will suffice for the chemical that's involved. The water floats are used in different API ranges. The considered application would be to whether they are a gasoline water float or a diesel water float, but with different grades of diesel, the API changes, and therefore at certain points some diesel-based products are too thick to support water floats, just as some motor oils or hydraulic oils are too thick to support water floats. Chemical compatibility. If your product is not chemically compatible with the product level indicators used, swelling, cracking, and dissolving may occur, leading to premature failure. Not only will the floats be damaged, there have been reported cases where the magnet itself in the float has been dissolved by the chemical in the tank. The float installation. On the bottom of the float shaft is a end boot and a retaining ring. That plastic end boot is to insulate the metal of the probe from the metal of the inside of a tank. You remove the clip and remove the end boot. You would slide the product float onto the probe shaft with a magnet at the bottom. Slide the water float on the probe shaft with a magnet at the top. Reinstall the end boot and the retaining ring. If you forget to put the retaining ring on, there's a possibility that the end boot can fall off of the probe when the probe is raised. Both floats would then fall off the probe, and you would have a water float on the bottom of your tank. You would have a product float floating freely in your tank, and you'd have to order new floats for the probe. A typical installation is shown in this diagram. Just the fact that we have two tanks, we have two probes in the tanks. The probes are connected to low voltage conduits that come into the building and into the, in this case, the illustration is for an EECO 2000, the left hand portion being the high voltage and the right hand portion being the low voltage section. Note that the junction box at the tank is labeled as a waterproof junction box because the probe circuits are intrinsically safe. Explosion-proof fittings are not required at the tank, just weatherproof or waterproof fittings. Probe specifications. The TLMB probe can be purchased in lengths from 4 feet to 12 feet in half-foot increments. The probe is labeled with a stroke length. That stroke length is 5 inches longer than the nominal probe length. So if there's confusion about ordering a probe, look at the model number that's on the existing probe that you want to replace. Look at the Q0400. That 0400-408 would be an 8-foot probe, 96 inches. The stroke length would be 5 inches longer than that, which would be 101 inches. So be cognizant of the fact that the stroke length is actually longer than the nominal length. Standard float sizes are 2-inch product and water, stainless steel shaft, and you can get stainless steel floats. It's intrinsically safe, has a temperature range of -40 degrees to 158 degrees Fahrenheit. When you purchase a probe, it includes the float kit and the probe cable. It also includes a new TLM driver chip, the version 4.3 driver chip that's required to support the TLMB probe interface to the EECO 2000. The probe wiring requirements. The probe wiring requirements change according to the distance between the probe itself and the TLM Interface Module. There are 4 different types of cable that we specify for up to 250 feet. That's the 8760 and the 88760, 8761 and the 88761. The difference between the 8760 and the 88s is the fact that the 8760 is a PVC jacket and the 88760 is a Teflon jacket, the same with the 61. For distances between 250 feet and 1500 feet, the two cables specified are the 9182 and the 89182 cables. These are larger cables for longer distances. Equivalent cables can be used. If not using the Belden cables, it is best to check with tech support to see if the cable that you would like to use is a compatible electrical characteristic cable. All probe cables must be installed in rigid metal conduit, or they may be installed in PVC conduit if a separate ground wire is installed in that PVC conduit from the ground at the console to a ground lug in a probe junction box. Probe circuit is intrinsically safe and must be wired in accordance with NEC and NFPA rules. Multiple probe cables can be in the same conduit, size permitting. There are no splices allowed. Each probe cable from the probe connection cable that is attached to the probe head to the junction box, from that point back to the TLM interface module, must be what is called a home run with no splices. Only one probe can be connected per cable, and the connections for the probe in the junction box at the tank should be sealed with an epoxy resin seal kit. What we illustrate here are just the general measurements normally used to make sure that you have enough clearance between the probe riser from the tank and any manhole and junction box that may be installed over that opening. You want to make sure that you have adequate clearance so that the probe can be installed and removed and wiring can be installed and checked when needed. The probe shaft should be at least as long as the tank diameter. The probe must rest on the bottom of the tank. It cannot be suspended in the tank. The correct water flow must be used. We don't recommend that you shorten the probe cable. Do not overfill the tank into the probe riser. Should you overfill the tank into the probe riser, there is a possibility that product will enter into the head of the probe. If product enters into the head of the probe, it will damage the probe. Need to ensure that the tip protector at the bottom end of the probe is installed securely so it doesn't fall off. And periodically, you would want to remove the probe from the tank. Check to make sure that there's no debris stuck to the magnets. Make sure that the floats have free movement up and down the probe shaft. The only actual annual maintenance that we recommend is that the probe be removed from the tank at least once a year and the shaft cleaned and inspected for debris. The probe float installation, we've covered this earlier. We show you again illustrations of the floats, keeping in mind that the 4-inch product float is no longer available. TLM probe connections. The probe cable that we are now supplying is a blue intrinsic safe cable with 3 wires and a shield in that cable. Those 3 wires are colored blue, black, brown. The blue wire connects to the cable going into the TLM interface module, the top connector. The black wire connects to the middle connector. The brown wire is capped, and the shield wire connects to the bottom connector on the probe connector on the TLM probe interface module. If the brown wire is connected, you will see multiple probe trouble codes being displayed on the tank monitor. The most prevalent being trouble code 62. As part of this presentation, we've included links for documentation. One of the documents will be a trouble code document, which will list the trouble codes for the gauge. You'll be able to look up those trouble codes and see what they mean. Epoxy seal pack that should be used is supplied with the probe. After the wires are stripped, twisted, and wire nutted, they should be inserted in the envelope with the epoxy mixture all the way up to the outer jacket of the cable so that the outer insulation is in the epoxy mixture. This prevents any vapors from traveling below the jacket of the cable into the building, because that would not be stopped by any seal-off that may be installed in the electrical conduit. It also prevents water from corroding the connections and causing stray currents in the junction box. Leak sensors. The EECO tank gauges support multiple types of leak sensors, different models, but all preceded with a Q0003 as part of the model number. This is the current family of sensors. Any existing sensors in the field whose model number starts with Q0001 or Q0002 are not compatible with the current EECO sensor interfaces being supplied by OPW. Those sensors will not work on current equipment, and there are no replacements available for those old sensors. If you have a unit that has an old sensor installed like that, that interface module that sensor uses is different from the interface module that's used today. So not only would you need to replace the sensor itself, you'd need to replace the interface module. We have both discriminating and non-discriminating sensors. And in the next section, we're going to go over looking at these different types of sensors that will interface. The Q0003-001 is a dispenser pan interface sensor. It is designed to be installed in a pan underneath a fuel dispenser. It will discriminate. It will tell you whether you have fuel in that space or water or both. It has two floats for low and high level detection, and it has a polymer strip to detect hydrocarbons that may be present. So we can issue a low water alarm, a high water alarm, a fuel alarm, a low fuel alarm, and a high fuel alarm. It uses a two-wire connection back to the leak sensor interface module, and in the unit it is programmed as a dispenser pan sensor. For diagnostics on the dispenser pan sensor, we've given you a listing of resistance reading for that sensor that indicate different states that the sensor might be in: normal, fuel alarm, water alarm. You could use these readings for troubleshooting sensor operation. The Q0003-002 is a STP sump sensor, or submerged turbine pump sensor. Essentially the same as the Q0003-001 dispenser pan sensor, except it is longer. Still has two floats, has a polymer strip. It's a discriminating sensor, detects water or hydrocarbons, and issues appropriate alarms for those. In the unit, it's programmed as an STP sump sensor. We give you resistance readings for this sensor also. If you'll notice, these are the same resistance readings that the dispenser pan sensor has. Again, these would be used for troubleshooting different states of the sensor itself. For both the STP sump sensor and the dispenser pan sensor, if the polymer strip is exposed to hydrocarbons, that sensor would need to be removed. This have to be cleaned with either mineral spirits or dishwashing soap and water, dried, and then reinstalled. If you inspect the sensor and that polymer strip is stretched out of shape, then that portion of the sensor is no longer functioning. If you want to retain the hydrocarbon detection for that space, you would need to replace that sensor. If not, that sensor programming in the unit can be changed to only monitor the floats on that sensor and to disregard the hydrocarbon, any hydrocarbon indication that would come from that damaged polymer strip. Generally, If exposed to fuel, it should be removed within 12 hours and cleaned. The Q0003-003 interstitial sensor is a discriminating optical interstitial sensor designed primarily for any interstitial space but fiberglass tanks. It's an optical sensor. It has two metal studs on the sensor. Basic theory of operation is a light is generated that strikes the prism on the sensor. The light is reflected back to a detector. If that lens or prism gets wet, then that beam of light is refracted away from the sensor and an alarm will be generated. The two metal studs are for hydrocarbon or fuel detection. If those are immersed in fuel, there will be conduction between those two and a fuel alarm will be generated. This uses a 3-wire connection and is programmed as an annual discriminating sensor in the sensor programming in the unit. If you wish to test this sensor, you must keep in mind that this sensor is designed to work in the dark. If you try and test this sensor above ground in ambient sunlight, it will not go into alarm because the ambient sunlight will be detected by the sensor's optical detector. What you would need to do is put this in a dark space, covered with a shop rag, something like that, so that you can restrict the light going to it to test to see if it will detect liquids. The normal resistance reading on this unit is given here, 35 k ohms to 45 k ohms. If you have a water alarm or a fuel alarm and the sensor is dry, that is indicative of a defective sensor. That is if the sensor is connected directly to the tank gauge for testing purposes only. Keep in mind that these sensors work off of a resistance that changes with different conditions. If your field wiring resistance comes into play, then defective field wiring can cause false sensor alarms if the resistance readings at the sensor interface connections at the tank gauge indicate what might be an alarm condition at the sensor itself. The Q0003-004 is a wet monitor well sensor. This is a discriminating sensor that will differentiate between hydrocarbons and other liquids. It is designed to be installed in a wet well. It has a polymer strip that goes down the length of the sensor. It has a water float at the lower end of the sensor. So any hydrocarbons that are floating on the water will be detected by the polymer strip. Should the water go below the bottom of the sensor, that water float will change position. The system will then indicate a dry alarm. What a dry alarm means is your sensor is not functioning because there is no water for the hydrocarbons to be floating on top of. In the unit, this is programmed as a water monitor sensor. The Q0003-005 hydrostatic interstitial sensor. This is for a reservoir sensor for a double wall tank that has a brine or other solution between the walls of the tanks. It's a non-discriminating liquid level change sensor. It has two floats and is normally installed so that the normal fluid level is between the two floats. As the liquid goes up, it would activate the upper float. As it goes down, it would activate the lower float and generate an alarm at the gauge. It's programmed as a normally open switch sensor. The resistance for this sensor, even though it is classed as a normally open sensor, when the sensor is in its normal operating condition, the resistance reading on the two wires would be 40 k ohms. When the sensor is activated in an alarm condition, that changes to 20 k ohms. So it's not truly an open and short like a float switch type sensor would be. So just keep in mind that even though it's programmed as normally open, there is a resistance reading associated with this sensor. The Q0003-006 basic interstitial sensor is a non-discriminating optical liquid sensor. It's used in the same spaces the -003 sensor is used. It just does not have the hydrocarbon sensing metal tabs on the sensor. It is a 3-wire connection, but it is, like I said, non-discriminating. If it alarms when it's dry, it's defective, and it's programmed as an annular, non-discriminating sensor. The Q0003-009 liquid float sensor is simply a magnetic float switch type sensor. It is open or it is closed. It's non-discriminating, detects any liquid. It is a 2-wire connection, and it is programmed as either normally open or normally closed depending on the float orientation. Usually it is shipped as a normally closed sensor. Should you wish to change the state on the sensor, there's a clip that attaches the bottom cover of the sensor to the body. You remove that clip, the bottom cover comes off. You can then remove the float, turn the float over, reinstall the float, put the cap back on and the clip back on, and you've changed the operating state from normally closed to normally open. This sensor is actually labeled interstitial sensor as an internal model name for OPW. Even though it's labeled as interstitial, it is used in sumps or any other portion of the installation where physically it can fit and monitor rising liquid levels. Keeping in mind that if this is used in a dispenser sump and there's liquid in the sump and it's wintertime and that liquid freezes, it could freeze and hold the magnet in place where the sensor would not function normally. The Q0003-010 vapor sensor. It's a hydrocarbon vapor detector, 2-wire connection, dry installation only. Any installation in liquid will cause it to fail. Normally installed in the lowest point of a monitored space because hydrocarbon vapors are heavier than air and would tend to sink to the lowest portion of the space. The vapor sensor is no longer accepted as a primary source of leak detection or release detection. It is acceptable as a secondary method, but not a primary method. And the reason is that when a vapor sensor is installed on a system, it must be adjusted for any background vapors that may be present. If background vapors are present, that means that something has leaked already. If the vapors do not increase but remain constant, that could mean that there is a leak, but other conditions that prevent the vapor concentration from increasing above the threshold amount. This is programmed as a vapor monitor sensor in the system programming. Next, we're going to take a look at the conduit and wiring requirements for the sensor connections and the multi-relay wiring. This also shows dispenser power interface wiring, but because that has been obsoleted, we are not going to cover it in this presentation. The leak sensor wiring, like the probe wiring, requires rigid metal conduit, and that's what's recommended. If PVC conduit is used, like the probe, we require that a ground wire be inserted in that PVC conduit and must be grounded from the junction box to earth ground at the console. All of the EECO sensor installation requirements do not require shielded cable for sensors. What we require is a minimum 18 gauge stranded wire to be used for sensor connections. Of course, this wire must be gas and oil resistant. One set of wires for each sensor with no splices. 1,500 feet maximum distance. As in the probes, we instruct you to seal the connections with an epoxy resin kit. As with the probes, multiple sensor wires are allowed in one conduit, size permitting. You're not allowed to daisy chain sensors in an installation. If sensors are daisy chained and one sensor goes into alarm, you have no way of determining without exposing all the sensors to see which one is in alarm. So most regulatory bodies will not allow multiple sensors on one circuit to generate one alarm for multiple sensors. So you see on the connectors shown on the diagram, for a 2-wire sensor, we use the bottom 2 terminals of the connector, and for a 3-wire sensor, we use all 3 terminals on the connector. For multi-relay wiring to an external alarm, the external alarm unit that we supply has 4 wire connections. One is labeled line, one is labeled neutral. That is a 120 volt supply that goes to that external alarm. And then it has 2 wires that are labeled float. Under normal conditions, one of those float wires would go to the common connection of a relay. The second float wire would go to the normally open connection of a relay. Keep in mind that these float wires, even though they are labeled float, have 120 volts AC on those wires, so be careful when working around these wires. So when the relay energizes, it will change its connection from between common and normally closed to common and normally open and activate this external relay. Should you want to control an external device, let's say that you want to turn off a device when the relay energizes, then your connection would be common to normally closed. So when it's at relaxed or unenergized state, that would be your circuit from common to normally closed, and on alarm, common to normally open would then open that circuit and disable that external device. Operation and reports for the EECO family. Operation concept, the programming of the EECO 1500 and the EECO 2000 is all menu driven. There are major menus and then sub-menus beneath those major menus. So when you get into a menu, you would use the up and down buttons or the next and previous buttons, depending on how those buttons are labeled, to get to different portions of the menus that you want to program. The system generates alarms and troubles. Both units have 3 indicator lights on the front cover: green, yellow, and red. Green is the normal condition. The green light could be solid or could be blinking. It doesn't matter. Green means normal. If you have an alarm, the red LED will come on. If you have a trouble, the yellow LED will come on. The difference between an alarm and a trouble means that the system has detected an operational difficulty with a device or circuit of the system. It is unable to operate properly, so it is going to generate a trouble alarm to point to the device or circuit that's giving the issue. An alarm is an actual alarm condition, whether it be a leak, a high product, a low product, or something like that. What an alarm means is it means that the system is functioning properly. It has detected a condition that exceeds one of the settings that you have programmed into the system. For reports, we've got all kinds of available reports that are automatic, some on demand. We can give you reports on the status. We generate reports on history, generate reports on leak testing, and generate reports on setup. Those functions can be found in the operator's manual. So, mentioned before, it's a scrolling menu for the programming of the unit. As an example, if you get into the setup to program the setup, you can navigate to the tank level monitor setup, and when you enter in the tank level monitor setup, the submenus that you would then see would be probe, product, tank, tank table, manifold, tanks, leak test, and alarms. When you get into each one of the submenus, that's where you would program individual devices and individual settings. The major menu selections under the system setup or general site setup. That's where you program in your name and address, communications parameters, things that affect the whole site. Tank level monitor, all the settings that you program for the tank level monitor portion, leak sensor portion, line leak detector portion, auto dial-up alarms. If you want to use the modem to dial up another device, you can program the unit to dial out on any programmed alarm or trouble that you choose. Auto reports is where you would print out automatic reports to be generated on a multiple times a day or a daily basis, and multi-relay programming, where you would program relays to activate on the alarms or troubles that you choose. Along with this presentation, we have included a link to a video that will explain the setup and show you typical programming on an EECO 1500 unit. Keeping in mind that the programming on the EECO 1500 and the programming on the EECO 2000 are essentially the same, the difference being that the EECO 2000 simply supports more devices than the EECO 1500 does. As a rule, trouble codes usually indicate some sort of a hardware problem. They may also indicate that some programming parameter is incorrect, but for the most part it's going to be a hardware problem. When a trouble code is generated, you can reference that code on a trouble code document that we've made available to you. This document will point you in the right direction, and it will give you hints of things to check or what to look at. The number one rule is to make sure that everything is seated properly, everything is connected properly, make sure that things haven't been moved around or that someone has not changed something in the program that should not have been changed. Easy methods to troubleshoot indicated hardware items like a probe or a sensor would be to swap that device with a working device to see if the trouble follows with that probe or sensor. If you suspect field wiring may be the issue, you could bring those devices inside the building and hook them directly up to the unit and test them that way. As always, you can call our toll-free help desk number and request assistance from our technical support department. This concludes this portion of the presentation. As I mentioned before, we have included a video that demonstrates the programming of an EECO 1500, a document that describes the trouble codes, a document that describes the field service tests, and a document that describes the programming of the unit. Thank you for your attention.